Okay, welcome all. This is a short presentation for civil engineering graduates or recently graduate civil engineering student as well as for undergraduate civil engineering students. The aim of this presentation is not to go on you shown you much details about civil engineering, rather it has a aim of providing you a bigger picture in terms of what can undergraduates of civil engineering can involve in. It also aims to provide you a insight how you will or you are involving in a civil engineering field. To do this, we have taken very short example or site visit just to give you a bigger picture of civil engineering, how you will involve in real life and how you can apply the theories you have learned from university or you are learning from university. So get started. The Again, the topic is lifelong learning for civil engineers, presented by NPA Civil Engineering and Project Management Consultant. Welcome on board. Visit us at www.draftinganddesigncenter.com for training. Email at draftinganddesigncenter@gmail.com. So again, as I said before, our audience is graduate civil engineer, those who passed out from the university, and civil engineering graduates. Now, having said that, civil engineering is a very broad topic, applies in all spectrum of infrastructure projects. In a nutshell, this is very small example I have taken when I was going off my house on the road, and I thought of making one presentations for graduates. So this is just sort of small area we have chosen. You might be involved in a hydrology, engineering, big project, dam projects, tunnel, and many more. This focus more on a street side only. So that just keep that in mind. Next, today we now cover planning and design and construction viewpoint and how civil engineering disciplines shall involve throughout the engineering and/or construction disciplines, and that involves traffic, transport, geotech, noise, structure, construction, drainage, lighting and survey, and utility. So starting from all aspects, how would you be involved uh, in terms of engineering and construction discipline of civil engineering? So I was just walking off my home and I took some snapshot. In fact, this is snapshot has been taken from GIS, Google Map. As you can see on a screen, there is a verge, curb and gutter, and edge of the pavement, and there is a walkway, concrete walkway too. As you can see, here is a concrete walkway. This is a verge, curb and gutter, and pavement. And looking in a broad spectrum, the view of the street looks like this way. So if we go back to the traffic, how we can involve in terms of deciding how many lanes we provide, where is the central line of the road, how many lane capacity I shall be able to provide, uh, different modeling aspects in terms of origin, destination, growth, using different application of the software, modeling different simulations, modeling small as well as large area in terms of traffic signals and the development together, and deciding based on a capacity manual how best we can provide a learning capacity Either it can be one way or two way, two line, one way, which direction, how many lines. So this based on a some sort of modeling approach we use to decide that. And there are a lot of sophisticated tools and techniques you might have studied in civil engineering. So all this to create a basic scenario from going into detail how the growth will be anticipated using that scenario, and developing some developing model using provided industry-based model, and coming up with a growth rate and density in terms of ADT for street, and deciding capacity and learning their own using appropriate standard based on your country. So these are the traffic we just sort of talked about. Now we can talk about transportation. As you can see on the road, all the way is straight. There is a bit of a sag in here, bit of a crest in here. This is draining this way. It may involve is sort of connecting this road. Then you might be involved in center line, designing the center line, making sure that how exactly road can connect at center, at what grade could be, how the visibility can be influenced when you driving the car, can you able to see and perceive entire movement, or maybe we can you drive it, and then when you turn it, can you able to see incoming and oncoming traffic to reduce the conflict, and you can able to perceive that. Some of the distance we use is side distance, approach side distance, intersection side distance, making sure that you can provide a good visibility, good environment, a good design in terms of reducing earthwork, balancing earthwork, and making sure that the vertical curves, horizontal alignment, and they both fine tune with each other, coordinate with each other, using different models you might have studied in university. So these are the things transportation side of street it might covered, using software based approach, using the surveying, understanding the ground, creating contours map, and from then on using alignment as well as vertical profile to be able to create geometry, and making sure that all principles of transportation engineering based on your country can apply. So now going back to geotechnical, so some of this different view of the road. For example, we can, before we design or plan as a civil engineer, we might involve in coordination as well as making sure that uh, if that road is capable of carrying a traffic, in terms of assessing the strength of the subgrade, as well as when we build up the road, assessing the road base strength of the subgrade, subbase, and base course. So these are the things when we create a construct something, making sure that we coordinate the borehole geotechnical report, and we wanted to get information about the strength of the soil profile, and making sure that what we build is able to transfer the load to the ground. So that regards we make sure that we know what we're doing in terms of building up the road, as well as the material when we cut and fill. Is that a material I can use for filling or cutting? Is that material worth to use it? Making sure at earlier the stage whether we can use the material in a good way, or we can discard the material, or we can store and use that material for building up the road. So these are the things we involved as a part of a civil engineering too. The noise is the always a issue we unsure about ensuring the traffic movement and then constraining the speed, how much the speed limit we provide. If it is a steep grade, hilly grade, much hilly terrain, there is a lot of interaction wheel and vehicle is happening, might involve the noise. We might have to construct the retaining wall, and that involves um, making sure that the speed limit is constrained. Again, that is type of the road we're talking about. This is street. So these are the things we involved in terms of defining the planning at early stage. Structures. Now, when we build up the road, as we are aware that the road has certainly different profile in terms of subgrade is able to take the load and transfer the load from subbase and base course and surface course. We gotta make sure that what the design is we provide sustains for design life. Design life based on what the standards you are using. For example, if it is a rural road, it might have longer life, less maintenance than urban road. So design life, traffic density, traffic count, environmental factor, heavy vehicle, and based on that, there is a different approach we use for designing of the road in terms of mechanistic imperial method and imperial method too. So these are the things we account to build up the structure, understanding the geotechnical and structure, and making sure that what we provide is sustainable. So these are the things we gotta make sure in terms of structure at planning during the construction as well. We make sure that what we build up is that based on available specifications standard, making sure that the aggregate we use is based on a criteria as well as the compaction we provide that is based on a reliability and what is the limit we uh, we can achieve based on a provided standard. Again, the weight of the compaction roller, type of the compaction effort we provide to be able to achieve the compaction. So these are the based on a constraint based on a geotechnical as well as traffic as well as construction that influence the structure. Drainage is again, as you can see here, the road is sort of draining this way, and there is a bit of a sag. It looks precise to me, and then again going straight onwards when the grade is falling this way, whether it can be able to get the capture of the water. For example, this is draining this way. There could be a inlet in here, as you can see here the road is draining here. There could be inlet here. The drainage again based on there are different types of the drain of the flow, calculating a time of concentration to the sag as well as high point, how the water flows, making sure that we calculate the optimum discharge to be able to design the depth of the inlet, and we can propose different type of the lintel length based on a calculated discharge, and that depends on time of concentration. Sometimes, as you can see here, is a inlet lintel is being proposed. It might be having a certain discharge as well as time of concentration. It then again takes a flow from property into the carbon gutter, and from carbon gutter there is overflow into the lintel. So there can be a roof flow, so the rainfall falls in, so there will be a roof flow from the property flows into the downpipe, and downpipe might have connected into the road. And from that point of connection, as you can see here, if I can zoom in here, there there is no downpipe connection is here. I can able to find some other figure. As you can see here, from this property, the water falls in here, and then it gets into the carbon gutter lip. All the way it falls down the lip and concentrate to the uh, goes to the nearest lintel or inlet. So again, calculating that property water flow as well to be able to optimize design. So these are all the factors we shall take into account when we design the drainage system, so that we don't see overflow when the particular event occurs. Again, deciding which how much occurrence we are using, average recurrence interval we are using, which event we are using to be able to design inlets. So this shall involve as a part of a engineering as well. Lighting has always been a good concept. As you can see, the light in here may be yellow and white lights depending upon the intensity. There is a bit of extension of light into the so that at night time visibility is maintained throughout the road, making sure that optimal distance between the light pole is available, structure of the light pole, and then foundation detail based on a load category. So these are the all things you might have been involved as a part of a lighting assessment and design based on the environment you will be involved in. Survey, as I mentioned earlier, is all about getting a real picture of the ground, how what is the ground is all about. There is a bit of crossflow of the existing road, capturing all information available on the ground, including maybe there is a valves connections, there is a bit of a driveways, curb, gutter, lip, centerline, road edges, bitumen, trees, spread of the trees, canopy of the trees, so that we can able to efficiently plan from that on and design and provide right information for construction. So these are the surveying information we require at initial stage. Uh, so that might be done by sophisticated tools and techniques and softwares. Utility plays always an integral part. There might be a different water mains, gas main, as well as fitting to the properties, as well as there is sewer main. How the depth of the everything, making sure that utility is protected and the life is enhanced throughout the life. And when we do uh, rehabilitation maintenance, making sure that the utility doesn't interference within the right of way. So these are the all consideration we provide at early stage and throughout the maintenance stage of the project. So in nutshell, for example, uh, there is a connection, making sure that there is a center line, there is a stop and dotted line, making sure that we could make sure that they align the center line here, both aligns very well with each other. It means that we have right filling when we do construction, making sure that the radius of the curve is easy when the vehicle accelerates and stops here and then turns. It can accommodate that maneuver, making sure that the traffic signs, for example, here is stop signs. If you provide stop signs, why we provide stop signs, why not give a sign? All the decision of signage, traffic, landmarking is we can able to apply at early planning stage, providing the no stopping sign so that the water flow doesn't get obstructed. These are all thing we can consider the height, the dimension, the pole, foundation, the material, all the thing we can consider at planning stage. Again, at construction, we make sure that coordination is smooth. The provided information at design stage is facilitated to construction stage easily, making sure that the quality requirement in terms of aggregate, compaction, uh, set out information, positioning, type of material we use, both are quality check. So these are the all life cycle issues we could have involved in. So I hope this presentation is very small and it may have provided you insight in different aspects of civil engineering, in terms of traffic, transport, geotech, noise, all the way down to utility. Again, this is a very short presentation aiming to provide undergraduate insight about what the branch is all about and how they will involve in a very small segment of example. Once again, thanks for watching, and follow us at www.draftinganddesigncenter.com, email at draftinganddesigncenter@gmail.com. Once again, thank you. Bye.